Oh, should be working. Let's start. So, hi everybody. So I'm the second guy from Quark's Lab, and there's the third guy there. So I'm the only one talking about our real jobs. They all speak about their fun stuff, and I have the less fun stuff. So as part of our job, we develop an LLVM obfuscator called Epona, and we have one problem. And this problem is that we have users. And users want documentation, but we are developers and we don't want to write documentation. And furthermore, we don't want to maintain our documentation. And that's the topic of this talk, how to do the minimal stuff so that users have the documentation and we don't write it or maintain it too much. Because there is very low support for documentation of passes in LLVM. If you ask for the documentation of jump threading, because you don't know what this, you can get the help, and jump threading is jump threading. So it doesn't help much. But well, we all know that the good way is to go through the code and then read the commands, and then you know what is jump threading, and maybe you can use it the proper way. So our problem is that in our obfuscator, we have the obfuscation from LLVM bytecode to LLVM bitcode, and we have this user directive. So the user can control how the compiler behaves. So he needs to know what every passes does. So our passes are obfuscation passes, but it's globally the same as any compiler optimization. And so how do we document that? Because the user is not an expert in compilation, but he needs to have an int. Because there are three ways for him to control the compiler. Either he uses good old compiler flags, but generally speaking, it's not a good way to control an obfuscation, because if you say, transform all constants in my code into something that is more difficult to understand, then you end up with very large code, and it's not performance-wise a good thing. So you can use directives, pragmas. So you say, okay, you're going to obfuscate this very function with this very obfuscation, and this is some parameter. And then this constant will be obfuscated using the heavy mode, which generates more code. But he can also write a schedule file, because he doesn't want to touch its file, so everything is put into a separate file, and then it's globally the same, the very same options, and you will apply this pass, then this pass on this function, and this pass on this function. So you have three ways to control the compiler. The problem is that how is everything consistent and how is everything documented without too much effort? We have one file. This file is located in the same directory as the pass, and it describes a lot of things about the pass. So it's not like Doxygen, which tries to document things. From that, we will generate various pieces of information that will be used either by the C++ code or by the documentation so that everything is consistent. So the level is like module pass, function pass, basic block pass. Block annotatable means can you use it as a pragma on just an instruction or a block of instruction, even if it's a function pass. The compile time overhead. From our measurement, when you use that, your compilation time is going to be multiplied by this factor, which is a big factor, but still. This is a textual description, and then you have all the options. This will be forwarded to CL, LLVM CL, but LLVM CL, it's global variables, which is very surprising to me, but still that's the way it is, and it doesn't place well with our directives because we want passes to be parametric, to be able to instantiate different passes with different options. So we have some wrapper to do that. We describe them, whatever, and we also have these classifiers because for random users, it doesn't know about opaque constants, but it knows that it's a data obfuscation. So when digging through his program, you know, okay, this is the path I can use to obfuscate my data. And it turns out that this path supports any targets, which is not the case for all passes, things about anti-debug tools or things like that. So from that file, you have the description. You generate some header files. So your actual LLVM implementation will derive from that, and it will get access to options, the good path level, and several stuff. We also generate the documentation that will be forwarded to Sphinx for user documentation generation. We also generate part of these classifiers, which is a big table that summarizes everything. And we also generate parameters for our test suites, so that we can test that the documentation is actually correct. And from this, we can we generate wrappers to CL, to the path manager code, and the actual class. So everything is generated from one file. So that brings us back to Literate programming, where you have the code and the documentation, and both are used to generate the whole tool, which consists in the documentation and the program, and we have something very similar to that. So there are several benefits of using this approach. First, everything is always synchronized. The documentation, the code, the directives, the path schedule, all the documentation you can get from the command line, the documentation you get from the documentation, everything is synchronized. So once it's written, you don't need to maintain it anymore. And nothing happens like you change the code but you forget to change the documentation, because the code is generated from the documentation. So this kind of step backward, which is really a pain, does not happen. Another thing is you need to support something else. As everything is generated from one script, from all this description, you can retarget it easily instead of changing the code for every pass. So that's very cool, because we write less doc, which gives time to my teammates to write their funny tools instead of maintaining the documentation. And just to... This is the kind of documentation we generate. So although it's generated documentation, there's actual interesting stuff here, code examples that explain how it behaves, and all this stuff here are automatically generated from the description. And it turns out that even us, we sometimes go to the documentation, copy that, and paste it, because that's what we want to do, and that's how documentation is often used. That's all. If you have any question, please feel free. Otherwise, it's Adrien's turn.